So welcome everyone and good morning. I want to thank Colin, Ed, and FMC team for being able to pull these webinars together. It does fill a need for our industry for convenient training, not just for the CEUs, but for the opportunity to learn without having to travel and spend a lot of money for that process. Here in Arkansas, it's a beautiful day. I am headed out on a 3-day motorcycle ride as soon as this ends, so we will be ending promptly. If I get behind, I will try to speak faster. Kyle's introduction was very flattering. It did list some of the things I've been able to accomplish in this industry, but I think if my next slide, I'm about to deflate any expectations you may have. I am from Arkansas, and many folks have never been to Arkansas and realize that we are about as hillbilly-ish as there is. I have a pet raccoon that actually lives in the house with me. If you ever need expertise on raccoon behavior, diet, temperament, I am your guy. So virtual sessions are not my favorite format. I like to get to know who my audience is before the session, opportunity to visit after the session. We're going to be spending about an hour or even less of an hour with the little breaks, talking about a topic that really takes years to master. There's a lot of innuendos and scenarios out in the environment that can dictate what our actions will be to mitigate or prevent termite activity. It will be up to you to try to get something out of this session, as though I will do my best. I really hope that you do, but your participation, your focus, and your engagement is what's going to win you some information out of this session. So some years ago, I was at a meeting with FMC. It was actually just a dinner meeting, but their representative stood up and started even that with a safety share, and it impacted me to where we implemented that here at our company. So we start all of our meetings just like FMC with a simple safety share. The one that's pertinent that we're talking about at our company quite a bit is that schools just got out, and we have to understand that there will be children in the streets playing, which have not been previous to this past week here in Arkansas, and I'm sure several of your locations around the country. And then also you'll have teen drivers that aren't very experienced drivers on the street. So we need to be paying attention to those individuals re-entering out into our work days as we move around our communities. So let's get into cockroaches, right? That's what this talk is about, eusocial cockroaches. Dr. Colby Shaw, an entomologist at North Carolina State University, completed DNA sequencing showing that termites split from cockroaches some 150 million years ago. And then as far back as 1934, some researchers had noticed the specialized microbes in the guts of termites, also present in the guts of some cockroaches. And you ask, why am I bringing this aspect up? Is many of us in the industry can relate to how difficult cockroach management is. And we understand that everything in their biology is about sustaining or thriving to move forward, to survive in the environment. Well, cockroaches have those abilities, probably even more so than cockroaches in some aspects we'll talk about. So what is a eusocial insect? They are one that is showing an advanced level of social organisms or organization. They cooperate while caring for their young. There is a division of labor among different castes in the colony or nest. And there are at least 2 generations present and active in the group. And so you can see that termites fit very well into the eusocial category. Not to get off on a tangent, but us as humans could probably learn some positives from the aspects that termites follow. But termites, are they good or evil, right? Many times when we're dealing with them from the perspective of our client or even our company, if we're struggling with being able to mitigate them, they're evil. We are just not happy to hear that we have termites. But they do play an important role in the environment by helping to break down and recycle fallen limbs, fallen trees, plant tissues, all that material that hits the ground in the forest. Termites help to break that down so that our environment can regrow and progress. but they do become an issue when they damage what humans hold of value. And so that that presents the question, what is the origin of our pest management industry? Why are we here? It's really to protect human health, which termites, I would say, not a great impact on human health unless you wanted to correlate mental health into that statement. And our clients are normally, their anxiety levels are through the roof if they have located termites within their structure, within their residence. And we do, to some degree or some level, become a counselor. We're not just pest management at that point. We have to reassure them that we will be able to take care of this for them. We will be able to prevent future termite activity, hopefully. And so I guess you could argue a little bit that there's some human health, mental health that we're trying to protect. Our industry protects food sources, rodents and all the other pests that damage food sources is a big aspect of what we do as an industry. Termites can damage some plants, some of the more aggressive termite species like formosans, but it's not a strong component of what we do in our urban pest management. And then property. So to protect human health, food sources, and property. And so NPMA reports that termites cause roughly $5 billion a year in damage. I've seen that figure reported as high as $9 billion. And so that's probably a really hard figure to quantify, but realize it's a lot. That's a lot. So for us, it is going to be important that we demonstrate value to every client. And by the way that we do that is exactly what everyone on this virtual training session is doing, is try to be more informed, to be educated, be able to use the proper terminology, to be able to understand the chemistries and how they work. All that, it will demonstrate value to the client. One aspect of this that we will not get into on this call, but it is your personal responsibility, is that every state normally has a little bit different rules and regulations or laws pertaining to termite management. Here in the state of Arkansas, we are required to maintain a repair contract, meaning that if termites get into the structure, we have to, at our cost, resolve the termite activity and repair that damage. I know a lot of states, a lot of individuals in each state offer that, but your state may not require that. And if you as a company operate in multiple states, you need to know what those differences are so that you can provide the proper protection for your clients. So we're going to focus primarily today on the eastern subterranean termite, although there are other species like the formosan and drywood termite, conehead termite, dampwood termite. So you need to be familiar with termites that are in your geographical area. By far, eastern subterraneans are the most common termite that we deal with in North America. Unless you are in the coastal states, you may be telling me, no, formosans are the ones that we primarily deal with. So termites are among the most successful groups of insects on Earth, colonizing most land masses except the Antarctic. And so back to their ability to thrive and survive, these creatures are, everything in their mechanism, everything in their being is about protection of the colony and protection of their own. An interesting thing that as our industry grows, again, not getting to know who all's on the call, there may be some companies here that their footprints of their company go into several different geographical areas with different climates. And so you will potentially experience different termite behaviors based off of where you operate. And it'll be your responsibility to understand that. We'll talk about some of those patterns here in a minute. Another interesting aspect is that if you're in a northern state, or maybe as you can see in this map, where the heavy pressure kind of clips the corner of Arkansas and Mississippi, Alabama, and fades out into Tennessee, and then you start moving north, the pressure is a little bit less. With the topic of climate change that's being discussed quite a bit, and there are documentable temperatures, whichever that cycle, whatever the cause of that cycle is, could potentially throw you over time into a maybe a higher pressure area than you'd experienced in the past 10 or 20 years. So that is something to learn and pay attention to. So I do enjoy philosophy. I enjoy comments or statements that have been written in history that strike a chord with me. This one is from Sun Tzu. He as if you know your enemy and know yourself, you need not fear the result of 100 battles. So what we're talking about today is we're going to focus that aspect of Sun Tzu's statement on termites and hopefully be able to correlate it to proper management of termites. The more we know about our enemy, the more we'll be able to properly provide the protection for our clients. And so this is where we get into sometimes not all the glitz and glamour of these presentations. This is the biology. Can be dry, but if you are excited about really performing high quality work, this is a necessity to be able to learn. So Eastern subterranean termites are Reticulotermes flavipes. Each individual in the colony goes through incomplete metamorphosis, which is egg, nymph, and adult stages. Each nymphal stage looks like a small version of the adult, but getting slightly bigger as they mature. We can think about a housefly, mosquito, where it goes through complete metamorphosis, which are egg, larva, pupa, and adult. And then you can correlate the difference of incomplete metamorphosis, where it's egg, nymph, which is a immature or small version visually like the adult. After the final nymphal stage, the insect then molts into the adult form. The adult form is usually often only distinguished by the size and then the presence of wings in some scenarios or some situations, and we'll discuss which part of that life cycle do manage the wings. So colonies, for them to be able to mature, depending on your geographical area, 4 to 10 years, and colony size can increase from several 100,000 individuals to even millions. And again, based on your geographical area in the country, in the South, we're going to probably have a quicker maturing population if all of their resources are available to them. But our colonies may be much smaller, and we may have more colonies within a designated area. I believe I covered that in a moment. Where up north, it could take longer for that colony to actually reach maturity, but by the time it does, its colony size is much larger and much more over a larger area versus a bunch of small colonies within a smaller area. Colonies that are described as superorganisms because the termites form part of a self-regulating entity, which means that and we'll talk about the workers and the soldiers and the queens, each one of them are dependent on the other, and they become self-regulating. If one gets out of balance, it's going to bring itself back into balance because it needs the other parts of that colony to be able to grow and thrive as it was intended. So Eastern subs, there are 3 castes within that colony: a worker, a soldier, and then reproductives, which are primary and secondary reproductives. The definition of an insect caste system is any set of individuals or a particular morphological type or age group or both that perform specialized labor in the colony. So the worker caste, let's talk about them first. They are the largest group in the colony. They consist entirely of immature males and females. They are soft-bodied and wingless. Termite workers do not have eyes, and they are sightless. So they are being able to move around the environment by using their antenna, potentially detecting moisture, detecting rigid surfaces like pipes, roots, and then also detecting pheromones that other termites may have laid down in the environment that they recognize as part of their colony and can use it to find a food source or to locate back to the colony after they have need to get back to the colony. The juvenile termites all have the ability to have additional molts to become soldier or reproductives if the colony needs or demands it. And so again, back to that biological trait to be able to survive, that these juvenile termites, if their colony is out of balance and they need more soldiers or more reproductives, they can molt an additional time and fill that niche for the colony. Workers perform all the labor in the colony. So clean and maintain the colony. Can you imagine a million little creeps running around that need cleaning up behind and maintenance of that colony? There's a lot of work being performed by those workers. They gather food and moisture for the colony, and then they tend to the brood. So you can see the key component of how important the worker itself is for that colony to have any opportunity to thrive or to maintain. Next, we have the soldier caste. They are much larger in size than the workers. They're also wingless and larger rectangular yellowish brown head with dark mandibles that are used for protection against enemies. And we can talk about that here in just a moment. Their primary function is to protect. They have a fontanelle, which is a frontal gland or pore on their forehead where they can secrete a compound that is a tacky substance they can use to defend the colony or ward off predators such as ants, which ants are primary predator for termites, but not the only one. They have a lot of predators. The soldiers do rely on the workers to groom and feed them, as they're not able to do that themselves. And the soldier caste only makes up about 1% to 2% of the entire colony. So they are a much smaller group, but their role is quite important for the colony to be able to survive. So this is a cool photograph of Formosan termites. When the mud tube was actually disturbed and broken open, they've lined up to be able to protect that until workers can rebuild that mud tube or block it off somewhere in the gallery, and then they'll retreat back into it. And so they're standing ready, looking for whatever predator may be to jeopardize that colony and try to fend them off. And then the reproductive casts, which are swarmers we commonly call, or another term would be alates. These are the ones that our clients most readily see when swarms occur. These are the ones that cause panic and grief when they come out by sometimes the dozens, sometimes by the thousands. These are the ones that are most readily recognized by our clients. So swarms often happen after a rain when humidity is high. This allows the swarmers to survive a long time above ground. The swarmers are the only termites that leave the protected environment and expose themselves to sunlight on purpose. The primary reproductives do have pigmentation and do have eyes, which these workers and soldiers do not. Termite colonies begin with a pair of swarmers that settle to the ground after their mating flight. If you've been doing this any length of time and have seen swarms, you'll see where the male and the female are moving through the environment with the male right on the hind of the female. What they're hoping to do is be able to find a crevice in the soil somewhere or a shelter place where they can begin to mate and begin to lay their eggs. The swarmers do shed their wings, and until they're able to produce nymphal workers that can gather resources, they'll live off the muscles from those wings for a period of time. But you can understand that is an infinite food source, and so they are in need of being able to get that colony going with that first brood of nymphal workers. These first foragers are really the linchpin and the whole potential success of a colony starting to develop. And so they immediately will start recruiting cellulose, decaying bits of wood, mulch, leaves, even pine needles, anything that they can find and utilize for the food source. The reproductives, the swarmers that do land and do mate, become kings and queens. They can live for quite a long time, up to 10 years. Unlike ants, bees, and wasps, the male reproductive termite, known as the king, will assist the female in founding the colony and remain inside the colony as a queen. Many of your other eusocial insects, the male is there for reproduction only, primarily, and then it is either discarded or kicked out or no longer needed by the queen. But in termites, it's different. The king sticks around and actually helps the queen with the colony. After the first year, a new colony may contain fewer than just 50 termites, or maybe even a few hundred after 2 years. But there's a centrifugal perpetuation that begins, that as that colony starts to develop, that fourth year and on, that they can really start producing quite a few termites and progress into a full mature colony. An estimated termite queen may lay 5,000 to 10,000 eggs a year. It takes about 5 years or longer for that colony to mature and produce its own swarmers, which is a key component. If you have a structure that has swarmers that you've located actually coming from that structure, then you can determine that that is a mature colony that is producing those swarmers. The population of a mature colony, again, is 50,000 to even millions of termites. And we'll talk about that. I think I cover that again in a little bit more detail geographically here in a moment. This is another component that shows their ability to thrive, right? Reproductives can be secondary and tertiary, which with established colonies, secondary and tertiary reproductives can actually outproduce the queen itself. These are reproductive termites that develop from some of the nymphs or workers inside the colony. The secondary do have a wing pad, as you can see in this photograph, but you can see they don't have the pigmentation. But tertiary reproductives would not have the wing pads. And again, these tertiary and secondary reproductives can actually outproduce the primary queen with egg laying once they're well established. Again, back to the biological ability to thrive, is that if something was to happen to the queen, say if a predator got to her, a mold, a fungus, something that caused her to die, the secondary and tertiary could continue to produce eggs, and that colony would continue to move forward even if the queen was gone. So let's talk about some facts. Swarmers on the interior of a structure is usually an indication of infestation, but not always. If we do have swarmers located in the structure, we should make every effort to try to locate where that launch tube originated from. But it is not uncommon for termites to swarm in the environment, say a tree stump, the flower bed, anywhere in the environment, even from a long distance. You know, if wind patterns are right, the swarmers can be blown towards a structure. They are light attractant. They may find their way into the structure around the entry point. We see that commonly. One of the things that we look for is if there are not wings inside the structure, and we cannot find the launch tube, we may lean more towards the possibility that the swarmers came in from the exterior. If we are able to locate wings on the interior, though, we may lean more towards that the swarm did come from the interior of the structure. Swarmers around the exterior of a structure does not mean the structure has termites, though. When we perform our preventive applications, we're treating the footprint of the structure. Depending on the chemistry, even if it's a non-repellent chemistry, there can be multiple colonies in the environment. And so you may still have swarms in flower beds or in the yard of that structure. And so that does not mean that your structure is in jeopardy. You need to really pay attention, though, to make sure. One of the follow-ups processes that we do is if we're not able to locate a colony and positively confirm where the swarms came from, we'll do another follow-up visit in 4 to 8 weeks to give time that if the termites are in that structure to show themselves so that we can positively identify that. One thing we want to do is not put termiticide in the environment that's not warranted or needed. And so we want to have a good, valid reason to do that by locating active termites in the structure. So this is a really cool photograph that MPMA has, Tom Myers took, but it does show all the different life stages. So we can see the worker, the soft body, cream colored worker. We can see the swarmer with the pigmentation, the equal length wings. We can see the secondary reproductive that has the wing pads that are not mature. And then we can see the soldier with the larger mandibles and the rectangular head. If you have termites and you're wanting to identify that species, it's important to try to collect soldiers in that process. There are many identification characteristics that are utilized through the soldier by the size of the mandibles or size of the head that helps in positively identifying those species. All right, this is something that all of us should be able to recite. And if not, there's a bunch of different graphics online that we can incorporate. But we should be able to just recite very quickly the differences of termites and ants visually. The easiest one when we're talking to customers is, looking at the termite that has a solid body or a thick waist. Even just standing up, not even bending over, you should be able to differentiate the difference versus an ant that has the pinch waist. Also, the elbowed antenna that ants carry, where termites have straight antenna. Those are very easy visual detectors that can be communicated to your clients over the phone. If we have the possibility to put that client at ease immediately, we want to try to take that opportunity by letting them know, hey, no, those are ants, swarmers, not termite swarmers. So this is important information. I encourage you, if you don't have something within your company, to put together a little flyer. You can put your logo on it. It can be emailed to your client very quickly if need be. All right, so we're going to talk about back to the identification, the ant versus termites. Smart devices like our phones are a very valuable tool that can be utilized by our clients, but also utilized by us out in the field. And we'll talk about some of those aspects in a minute. I enjoy verbal conversations more than text, but I'm a little bit older generation. Being able to communicate with our clients through phone call, through texting, through video, through photographs, providing reports immediately. Those are all very valuable aspects that we can utilize our phone besides games, right? Our clients can be incorporated to help us with that. Many of us that are asked to identify things through photograph, which I'm not a fan of, because we get little black smudges on napkins and asked, what is it? And so one of the things that we did, and this is actually not a very good photograph, but within a matter of maybe 10 minutes, I put this flyer together for a customer one day, just in our little conference room, giving them some direction of how to take a proper photograph of a specimen. And obviously this is not a termite, this is a bedbug specimen. I would recommend that you possibly do something like this in-house if you haven't. It's something you can share with a client very quickly through email. They, in return, send you a better photograph where you can properly identify what the problem may be. MPMA Technical Committee is working on our project for this. So if you don't have one of these in your company now, that we're going to put together something through MPMA to where you can just go to the MPMA website, download the little flyer and share that with your customer also. All right, so foraging and aerial colonies. This gets a little tricky when we start dealing with colonies that do not have to have contact with the soil. Termites forage somewhat randomly by tunneling through the soil and over stone or until they encounter wood. They'll follow roots, plumbing, buried electrical lines, sprinkler lines, things of that nature in the environment. But a majority of the foraging is done in the top 6 to 12 inches of soil. Once they encounter a food source, the workers will recruit others to that source and begin feeding. This is done through a pheromone that they'll lay back as they go back to the colony. An average subterranean landscape can contain several different termite colonies, up to 25 in an acre in the southern states. But in the northern states areas, there are fewer colonies, but they are much larger. They can have millions within that colony. That's what I was describing earlier. Here in the South, we may have 25 different colonies, all within just an acre or maybe a lot that a home is built on. And so our structures are continually being pressured if we're using a chemistry that is either repelling the termites or a non-repellent that's helping suppress that overall colony population. We have more colonies continually moving into that environment and pressuring that structure. So the question is, can eastern subterranean termites survive above ground without contact to soil? And the answer is yes. And this gets very, very tricky and can be quite a challenge to resolve. So if there's a alternate moisture source above ground, which we have seen just water lines that condensate, we've seen A.C.E. ductwork that condensates, we've seen condensation trays and attics that are dripping. You see where eaves are leaking around fireplace chimneys, and so there's moisture in the soil. Our technicians go out to resolve the termite activity or try to prevent the termite activity. And so they are focused at ground level as the most common termite access are made, and they don't pay attention to the alternate moisture sources. And we have a return visit in the future to deal with active termites in the structure. So this is something to be aware of. It's easily overlooked when we're doing training with our technicians or when we're in the routine of looking at structures to prevent termites. We focus at ground level so much we forget to look high and look at these alternate moisture sources. So one of the most obvious things that we're looking for is obviously mud tubes. So termites can't live in an open air environment. The workers will desiccate, and even the swarmers can desiccate relatively quickly if they don't get back into contact with the soil. So these mud tubes are actually protected environments that termites use to get from the ground up to their food sources. And they're able to control that moisture and that humidity inside that tunnel by carrying moisture up from the ground. But that has some limitations, right? They can only carry so much moisture so high before that they're not able to get any further above ground. So this is the same mud tube at the base that we just looked at prior. And you can see when we break it open, all these termites that are moving through it as just a super highway to gain access from the crawl space interior up to the sill plate in the structure. And then when termites do swarm, they create launch tubes. And so this is one of the things that we're looking for. They will normally try to, even if it's just at ground level, build a launch tube a few inches tall at least, but it's not uncommon to see them either head high or waist high popping out of a sheetrock. In this photograph, one of our technicians had found a launch tube in a crawl space where they had stored their hot water tank and utilized the side of that hot water tank to get as high as they could to swarm out. Ironically, they ended up just swarming out on the inside of a crawl space, so they still weren't able to really launch out. One of the things with being able to swarm is they're hoping to disperse their DNA. I don't think they hope, right? This is just biological to them. They don't have feelings, but if they are continually inbreeding with the same population, that's not a good thing. So they're looking to swarm out and hopefully find swarmers from other colonies and to strengthen that DNA by mixing it with others than their own. So. All right, so we're getting into again, another very important part of being able to communicate to your customers, especially when we talked about mental health and anxiety and things of that nature. So termites are one of the few animals that can utilize cellulose as a food source. There's not many of them on the planet. Termites do eat mostly the spring wood and leave the hard summer wood behind. And we'll look at some photos here in a moment. And that's important because other pests do not. They will damage the summer wood also. Termites have a symbiotic protozoa or other microbes in their gut that helps them to digest that cellulose. There's research that has been being done for years. I really don't know where it's at now, but attacking that protozoa and those microbes so that if they cannot digest the cellulose, that's going to greatly impact the termite population overall. All right, so this is that really important caveat that if we can learn, we can really kind of help people put our customers at ease, especially when they're calling in. They say, hey, I need someone right now, immediately, and it's either late this afternoon or tomorrow before you can get there. You can kind of put their mind at ease that their house or structure will not be damaged significantly in the next 12 to 24 hours. A 60,000 member colony can eat about 1/5 of an ounce of wood a day. And that equates to about 2 linear feet of a pine 2x4 in a year. Okay, so that's pretty slow progress to damage. Versus your Formosan termites, which if there's any folks from the Gulf coastal states, the Formosan termite can do about 1 foot of a 2x4 in only 25 days. And so you can see the difference in the amount of damage that these two different species can do pretty quickly. So identifying termite damage, this particular photograph, if we're expecting and only have the visible opportunity to see just the end of that 2x4, this can be difficult to detect. You notice a couple of pinholes, a little cracking. This is the same 2x4 from the side, though. There was significant damage done to this 2x4. If you look in the photograph, you can see the mud tubes that were deposited by the termites. You can see the spring wood that got left, or the summer wood that got left behind, where the spring wood itself is what was deteriorated. And then you can find them in areas that also are sometimes right in front of your face. They're not common areas that are easily overlooked. I've actually got this this picture in my office now as a display. This is a client that was in a huge warehouse building. They had a conference room they rarely used. In the interior of this building, I'd say it was probably 50 or 60,000 square feet. And they contacted us because termites, they didn't know what they were, but they were actually termites just lined up at, like pigs at a trough eating the backing of this, this picture. There were no other signs in the structure anywhere. And so we were able to locate an expansion joint in this large building. The foundation's poured in sections. So the termites were able to exploit a gap and move up into the wall. It's not uncommon that you do find termites behind furniture in a structure, behind pictures or things that are on the wall. As moisture is trying to escape that wall, the picture or the furniture can restrict that. So you have a little bit higher moisture level there, and termites will gravitate towards those areas. So it's important for us to be able to get our eyes behind these things when we're doing our inspections. In this particular one, the termites had just bridged that little gap between the picture and the wall, and were able to get into a food source and do significant damage. Then the other thing that we see quite a bit is moisture damage that can be misconstrued by our customers and even our more inexperienced technicians that this is termite damage. One of the things that we train to look for is the more checker patterns that are caused by moisture, and then the lack of soil that's in those galleries that termites would utilize if they were in that area. And then you have carpenter ants, which again, they'll go across the grain of the wood, and then the galleries will be quite clean. So as part of Sunzi's information that we need to be as informed as we possibly can, we have to understand not just the biology of the termite, but now we have to understand construction methods that termites will use to exploit or to gain access to different forms of construction. And so there's several different construction methods that are probably prevalent in your geographical area that may not be in other areas. Again, if the footprint of your company covers a large area, you have to be familiar with each one of these. Monolithic slabs in our area is pretty common. This is where there's a solid pour of concrete and you have fewer gaps or cracks that termites can gain access. Your main focal points are going to be where plumbing breaks are, where plumbing comes through the slab to feed water into the structure. You have supported slabs, and this is where the footer is poured and then the slab's poured across the top of it. This does, especially if the grade of the soil is poured over the top of that slab that rests on the footer, that leaves a gap where they can bridge possibly your treatment that may be under the soil or under the slab. FMC's product Totality is one that we do use. So you can think that if we were to treat this 2x4 stud all the way around the house with Totality or other wood applied products, we're again another layer of protection for that structure if that was to occur. Slab. This is the one I dislike the most when I recognize this is how the structure is built. In this particular diagram, you can see that this footer is poured and then the actual wood stud wall is set to the edge of it. It's not uncommon that it will be set more on the seam of where the slab is poured, and they leave an overhang for the brick ledge for the exterior. So termites can exploit this gap between the concrete slab and the footer and go directly into the base plate of the wall and never be detected until the damage becomes significant enough to where it becomes visible outwardly in the structure. All right, let's go. So we're going to demonstrate through photograph some of the areas that we'd want to focus our treatments, or not just our treatment, but our inspections when we're trying to detect termites. So anywhere that there's a plumbing break in a slab type construction, right? This can be bathrooms, this can be laundry areas. In this particular photograph, there's a closet that's on the back side of this that would be right adjacent, right next to where these termites may enter into the structure. And so we'd want to get our eyes on the back side of this as well. So maybe more obscure places that termites may utilize to enter is a hot water tank plumbing breaks. A lot of times this is stored in an off closet, maybe a more obscure area of the structure in the garage. And so these would be conducive areas, obviously where any sink or plumbing lines come through. So in the homes that are being built today, these things are sealed so well with Tyvek and other moisture management systems that they're keeping moisture out. But if moisture ever finds its way in, it's actually restricting the ability for moisture to escape. And so around windowsills is a very common place where you'll have higher moisture levels, which again is conducive to termites. And so it's important that we do inspect windowsills in the structure, and not just from the top, but we need to get down to where we can see underneath where that seal, that crack may be. We may see a little dirt. We may see sometimes wings in the corners, things of that nature where maybe we've had swarms in the past. And then on foundation homes, there can be obscure entry points. This was unfortunately a home that we had under policy. Termites did gain access through a crack in the foundation that was not visible in any inspection until the termites started to actually damage the wood floor. So termites can pass through cracks 1/16 of an inch or smaller, or even a little bit smaller. So most slab structures do crack. And so that is something that we really need to pay attention to not just focus on plumbing breaks, but also complete inspections of those structures. So crawl spaces are another common construction method in our region, and I think they're really common around the country. And so this is where there's normally an enclosed area by a foundation wall, and then the wood beams are placed on them, and so there'll be a void underneath it. If there's a crawl space, that has to be inspected for termites because it's very common for termites to utilize. In those environments, it's important though that we wear the proper PPE. That is a more of an environment that is conducive for fungi and sharp objects and things of that nature. So I do want to point out a little technique. If it looks like a solid floor, we teach our technicians to do a foot tap, and that's where they're just basically just tapping their foot on the floor and they're listening for hollow sounds. This particular structure was a hidden void underneath that our technician was able to locate by just doing the tapping technique. If you find a hollow void, it's going to be imperative that you open it up and gain access to that. So again, back to understanding, to being informed of our enemy. In the state of Arkansas, we're required to provide a repair contract. And so it's important that we document, we use the proper terminology whenever we document anything. You and your geographical area, what we deem as a header may be called something else, or a seal plate, you may call a base plate. It's important that you understand what that terminology may be in your area so that you can communicate amongst yourself, but also to your clients and then to any regulatory people that may get involved. Plenums and in-ground ductwork is something that we do not see a lot of, but you need to, if you see a concrete slab and there are ductwork in that slab or ducts cut through that slab, that becomes a bit trickier in termite management. And you, unless you are well versed in it, I would ask that you probably get a second opinion of how to manage that, because termiticide cannot be placed in where that airflow would be and exposed to the inhabitants of that structure. And then you have basements, which are fairly common all across the country. And they, you know, part of that structure is buried below grade. And knowing that we're dealing with a subterranean creature and there's wood members below grade, that creates its own set of problems that can be pretty complex and sometimes challenging to manage. You should be able to have all the proper inspection tools, like a screwdriver for probing or sounding wood, pliers for pulling back edges of carpets, cell phones for photographs, looking around corners. You can take a picture and then pull your phone back out and see what maybe you can't get your head around or your eyes around with. Man, the flashlight technology that we deal with today is phenomenal versus when I'd started in the early 90s. They're very durable, bright white lights. One technique that we teach is to shine that light at an angle, and you can see in this photograph where every little texture of that wall becomes visible through shadow. And so if you have termites that have done some discrete damage to that wall, a lot of times using your flashlight at this angle will show it versus aiming that flashlight straight onto that wall. Conducive conditions. This is something that either structural or environmental conditions that lead to the pest problems provide all the resources, food, water, and shelter that the pests deal with. Many of the devices we're going to talk about following exploit those conducive conditions. And so one of them is canine inspections. Many of us that have been in the industry for the last 10 years, bedbug canine became very prevalent. We're very familiar with that. But if you haven't been in the industry 10 years or so, prior to that, canines were used for termite detection. Some of the studies that show that they were 95% effective in finding emissions that termites give off, like methane and CO2. But that became very dependent on the actual canine trainer itself. Here in Arkansas, we've progressed to the next level, is that we've moved past canines and we've been testing raccoons to see how that works. They can actually climb and find some more discrete areas that canines are not able to do so. Moisture meters. This is an invaluable tool. So termites have to have moisture. If you can detect the moisture, a lot of times you can find where the termites are without them making themselves visible, without having to do exploratory openings and wall voids and things of that nature. There's a couple of different kinds. There's some that have pins that you actually have to put the pin in the wood. And then there's pad sensors that actually are sending a signal through and then receiving that signal and picking up on the resistance or lack of resistance in that wood due to the moisture. These are readily available in our industry and important to have. Another one that's emerging is thermal imaging. This is actually a photograph that we had of termites in a ceiling of a sunroom that was added onto a structure. We were able to locate where the expansion joint was and the moisture that was being pulled up into the wall that allowed the termites to get that high up into the structure itself. You do have Termitrack, which is a radar, and then it also does thermal and moisture. These are great tools if you're incorporate them. Bore scopes, where you actually can see into the wall void with a camera. These can be utilized a lot in other pest issues, but it can be helpful in determining access points for termites. Magnifying glasses for specimens to look at frass if you got drywood termites or wings, things of that nature. Sound detection, right? We do have stethoscopes. They're rarely used, but they're cool to understand that termites, when disturbed, can bang their heads and cause a rattling sound, and that can be detected through sound detection. Environmental conditions, right? Wood sitting on the soil. This is something we should be able to document. Alternate moisture sources. Wood into contact with soil. That's never a good scenario in any facet. So that's something we should be documenting in our diagrams. This is a very basic diagram, which is sufficient, but you can also get into much more complex diagrams that lay out the whole environment and point out the conducive conditions for the customer itself. We have expandable foam that is being more prevalent in our industry, as well as what we call ice block construction here in Arkansas, where this styrofoam holds moisture. And so termites can readily move anywhere in the structure once they gain access. Same thing with stucco. Stucco is basically a styrofoam with a concrete covering on it. So a definition of an expert is a person with extensive knowledge, experience, or occupation and in the particular field of study, and that's you. So demonstrating value with every client, I encourage you to be the expert. And guys, if you got any questions that I didn't cover, any comments, please feel free to shoot them to me in email, and I will definitely get you an answer and close out the session.
Hope everyone has a great weekend.
Thank you, guys. You have a great weekend.
Right.
Thanks.
You too.